Your software and your hardware is no longer like, I'm going to run this generative AI program on whatever infrastructure happens to be available. Computational asset is no longer a commodity. It is the advantage. It is the requirement. And software is an important and critical part, but they have to be highly integrated. How do we reuse more of the components? Like, why are we throwing away so much copper from the power supplies every time we want to upgrade the chip? Well, because the power supplies are built in the server and we just throw the server out. Without hardware innovation, there's no way you get 1,000 times or 10,000 or 100,000 times better, faster, cheaper, more efficient. Just unbelievable when you take and optimize hardware around a workload, what you can do. It's incredible. There's so much work to be done. It's such a big industry to accomplish. More diversity in software and hardware, in technology in general, is good. That creates more innovation.
My name is Brian Schechter. I'm a partner at Primary. Today, we're talking with Zachary Smith, founder of Voxel, Packet, a hardware industry veteran for over 25 years. Our conversation is far-reaching and gets into what is perhaps the hottest area of startup land right now, which is compute. And we're at an interesting moment in history where all of a sudden the hardware matters. Zach has true pulse on that reality, but also an understanding of all the complexities associated with bringing experiences to market for end customers that we're going to hear from him talk about.
So I'm Zachary Smith. I live here in New York City, but I originally grew up in Southern California. Basically, the vast majority of my adolescence, I was convinced I wanted to be a musician. And so I studied the classical double bass. I started in 4th grade at the elementary school, and for no other reason beyond the teacher who came in to demonstrate the bass was like 6'7", and I was much shorter than 6'7". I was a little twerp, and I thought I somehow made the association in my head that if I played the bass, I would also be very tall one day. It has not worked out exactly that way, but so I started playing the bass. I went through school, and my junior year of high school, I dropped out. Didn't love an answer that a high school guidance counselor told me, which was something to the extent of I had to wait till my senior year to do my last remaining English class. So I dropped out, and I took my GED and spent the rest of the year kind of practicing the bass, and applied to colleges that would take me early. And I ended up moving here to New York to go to Juilliard, which was an awesome experience, where you just get surrounded by incredible people who are very, both motivated on their own and also self-critical, which were two things that I used a lot throughout my entrepreneurship. So I went to Juilliard, I played bass, I was studying for several years. I ended up graduating, but by the time I was leaving school, it was very hard to pay my rent. I was, kind of supporting myself here in New York, and there wasn't any clear prospects for a musician's salary. And so I had some temp job, but while I was there, I decided I was going to start my own business. And I reached out to a family friend, a guy by the name of John LaRue, who had started a CLAC. He was the only kind of entrepreneurial person I knew in my life. And I asked him, John, should I start my own company? And should I do a phone company? And he said, absolutely not. But you should do something with recurring revenue, because if you can sell it once and treat the customer well, they'll keep paying you. And that's a really, really good business. And so he said, do you have anything that you know that would have recurring revenue? And I said, well, all my musician friends need websites. This is 2001. And so I decided I was going to start a web hosting company for musicians. And I went online at like 2 a.m. in the morning and started posting on forums about I learned about this Linux thing, which I was calling Lunix at the time. I didn't know how to say it. And started reading books, and eventually ran into this gentleman, Raj Dutt, online, who responded to some of my forum requests and said he could help me start doing virtual hosting. And I bought some servers or rented them from him. And that was how I got started with my own business. Couple months later, and I had 100 or 200 customers from my musician friends, and I quit all the other jobs I was juggling and just focused on that full time.
Keep going all the way at this speed, please. And then I want to come back to like what you had to learn, because that's going to be, we're going to kind of build from there. But I actually would love to like do the full arc so that we can then know where to hop around. But that is, I've got a lot of follow-ups right there, but I do want to get the full journey first.
Well, at 21 years old, I figured I had nothing to lose. And so I said, if I'm going to start some business, I'm going to do it now. I went up and drove to Troy, New York, which is where this big company was based that I was renting the servers from. It turned out not to be a big company. It turned out to be Raj and a couple of roommates running a Linux hosting company, and I was one of their select customers. And so we decided to go in business together. And this was just after the .com crash of 2001. And I was down here in New York. They were up in near Albany.
So when in 2001 is this?
This is September, just after September 11th.
Yeah, okay.
Yeah. And we decided, the whole world, like all the .boom stuff had kind of started to tear down. And I said, well, I better make a go for it. And we just kind of benefited from good timing, actually. Some might consider it awful timing. It was good timing. Why? What Raj had built, a company called Voxel, was only focused on open source Linux-based systems. And the whole world was moving from proprietary systems like Sun Microsystems and Microsoft, because they didn't have any money, but this internet side of content was starting to happen. DoubleClick had just emerged, so people were starting to have advertising models, but there was a lot of rich content that was starting to show up online with no real way to monetize, and all the venture capital had just got sucked out of the market. And so people were really open to new ideas about how to leverage open source. Linux was considered somewhat of a redheaded stepchild at the time. Nobody would seriously run their application or website or whatnot on Linux. They would need Solaris or something like that. And so we kind of entered as that other company focused exclusively on Linux. And that was where we kind of plowed our craft. And it was a great time to be in the internet.
And what's that business called?
Voxel.
That's Voxel.
Yeah.
Web hosting.
Yeah, web hosting focused on open source. And we also had built something that we weren't afraid of. We were probably more of a software shop than we were an infrastructure shop. We had built an open source at the time, and then later closed sourced it as a SaaS product, billing, client managed metering platform. And we had licensed it to hundreds of other hosting companies to kind of pay our bills. And that really enabled us in, I think it was probably 2004 or 5, to launch the first hourly based consumption cloud. Because we had the backend systems to be able to bill by the minute, bill by the hour for VMs. And so we'd worked with Zen to kind of launch a virtual machine based on open source and bill for it by the hour. And that was one of the first public clouds. So
it's 2004. Voxel is both a web hosting service and a software solution for other web hosting solutions.
Yep.
You're basically enabling the sort of early first cloud.
Yeah.
What happens to Voxel?
So we kind of grew that business. We were bootstrapped, and I'd like to say we borrowed from Peter to pay Mary to ask Jane if she could lend us a quarter from Phil, or something like that. Which is why we had all these things like selling our software to our competitors and things like that is to pay. And then 2008 happened, and the financial crisis, round 2, right? But at this point, we had a lot of leasing. Running a public cloud is expensive from a capital perspective. The basic rule of math is for every dollar of recurring revenue, you need to spend $10 to $12. And so just think as you start to grow faster and faster, it was really hard to grow fast, actually, because you just would run out of money. And so we had bank debt and leasing and credit cards and everything we could do to take this cash flow, which was becoming pretty big.
How big?
I mean, at the time, we were probably a $20 million a year business, So it was like starting to be, you couldn't fudge the number, let's put it that way. And then 2008 happened, and our business took off because everybody was themselves, enterprises and other internet companies were short of cash. And so they started leaning in heavily to hosting companies, public clouds, et cetera, because they could offload that capital expenditure. And so we definitely stopped paying payroll a few times. We, $0 in the bank. We just would take what looked like a good order and then try and figure out how to buy $1 million a year,
Wow. As a hosting company that time, you are taking on equipment risk.
Absolutely.
Okay. And where was the equipment going?
We were in a couple places. We were in data centers like Equinix. We had taken over some of our own facilities. We were all over the world. We were in, I think, 15 or 16 locations around the world at that point. We operated a CDN, global DNS network, IP network, and these kind of hosting locations. It wasn't really that we wanted to operate so many of these. It was that we never could get enough scale to take a big lease or a whole building. And so we would take what we could and fill it up, and then we'd have to connect it to something else. And so we ended up getting really good at networking.
I would love to hear you give me the dummy's guide to a CDN and a DNS.
Sure. Well, it was all along this vision that we thought customers, and going back as early as, I can remember having conversations with Raj, we would walk around Lower Manhattan. We had taken over some data centers in Lower Manhattan after the banks had left. So there was some capacity available. And I remember walking with him because he and I just really believed that end users, we didn't call them developers at the time, they were sysadmins. They really wanted things handled in a more consumptive basis. Why would they want to pay for peak demand when it was, a low time on a Thursday? And so instead of being constantly pressured on pricing, which is what people would do, they say, I can't afford this for $5,000 a month. I can only pay $3,000. And what we would say is like, well, what you really mean is you only need certain amounts at some time and need different amount at another time. And so first we had built, kind of on-demand, hourly-based virtual computers, right? We had done virtual dedicated servers where you could buy them by the hour. And then we said, but why do people even want a server? What are they doing with it? They're running Apache or some web server all the time. Why don't we just give them HTTP threads on demand? And so that drove us into building a CDN. And so we said, we'll give you on-demand access to web servers with bandwidth. It was like image hosting. And, we had one of our first customers, it was Imgur. It was getting very popular with GIFs at the time. And, it would just peak. And he just wanted to have, Alan wanted to have HTTP on demand. And there weren't really accessible CDNs at the time. Akamai was around and a few others were starting, but it was really, pretty select. So that's what led us into a CDN. And then you immediately realized that you had to control traffic. And
so hold on. So CDN, Content Delivery Network.
Yep. So servers all over the world, placed so you could distribute the load and effectively serve some sort of static content at the time, which was like a web page or an image or whatnot. And then you had to deal with things like caching and those types of issues. But then the big problem was routing traffic. What if you had to take your Singapore location offline and route all the traffic to Hong Kong? And so we hired a gentleman, Chris Beavers, to build us a DNS orchestrator effectively, because using BGP, which is the main protocol of routes on the internet, was too coarse. You couldn't control traffic enough. You needed to give somebody like a URL and then change the answers of the A record to go to Hong Kong instead of to Singapore, so you could route traffic. And we also were doing it for our own traffic engineering. Maybe we didn't have as many servers in Singapore as we did in Hong Kong, or maybe there was too much traffic going to one location or another. So we built a DNS network to kind of manage that. So, this logic eventually, I know Chris rebuilt it a couple times and got so sick of it. After we sold Voxel, he started a company called NS1 just to do DNS traffic management. And so, we had to build a lot of these things along the way. I think it's kind of my journey into being not too scared of the whole stack, because you didn't have a solution. You couldn't just subscribe to Route 53 because it didn't exist. So I had to kind of be silly enough or stupid enough to say, why don't we build it?
So when does Voxel chapter end?
Yeah, chapter end. So 2008-9, very scary period for me and Raj. We went looking for money. We struggled. We almost sold the business for basically nothing. And then we met a gentleman by the name of Raul Martinek. We didn't know how to spell P&L. We weren't very good at our financials. And he came in and he said, wait. You mean you're about to go out of business because you have too much revenue and everybody wants to buy the thing that you've already built? And we're like, yeah, I know. It's a really silly story. So he said, well, why don't I join you as CEO and I'll help bring the capital? Because nobody's going to invest in you scrawny 28-year-old kids who don't know how to spell P&L, but they'll probably invest in me. And so Raul came on board and we raised some money from a private equity firm called Seaport Capital, who had been investing in the data center space. That went really well. And within 18 months, we were acquired by a public company, a firm called Intermap. They had built an IP network and a data center platform, and were trying to get into the cloud at that point. They were one of the first OpenStack users, if you're familiar with that. And we weren't looking to get acquired per se, but the offer was good. It was meaningful for me and Raj, who had, basically bootstrapped and hadn't taken a paycheck for, a half decade or so, right? And also we felt that the landscape of the cloud was shifting, that the hyperscale clouds, we're always very afraid of the hyperscalers. Remember at the time, we had hundreds, if not more, over 1,000 people using our billing software. So we could see the trends of different hosting companies. And what became super clear was that these ecosystem-driven clouds, Google had launched App Engine at the time, AWS was well on its way. I mean, these had really, really robust advantages. First off, they had capital access that we just didn't have. Like the depth and the cost of their capital was really, really impressive. And then the other thing is that they were doing data centers through databases. They were going all the way up. They were starting to introduce services higher and higher up the value chain, which made it very difficult for hosting companies, pure play infrastructure businesses, to kind of exist independently. And so we took the offer. I think it was good. I learned a lot about M&A at that time. It was a severe education. And then we got acquired by that business. I left within a year. I was running their a division for a little bit, but I think I found out pretty quickly that I wasn't mature enough or loving, being part of a corporate public company structure. It was a pretty big shift from being an entrepreneur. And Raj did as well after a little while. And I vowed to never again get into the internet infrastructure business. I was super fortunate that a lot of people from that original Voxel crew ended up creating new businesses. So Chris went off and started NS1. Some team members of ours joined and started a business called Kentic, which was like network analytics. And, other people started creating businesses. Raj went off and founded Grafana. He was always very interested in open source and observability. And I had spent a lot of time in Lower Manhattan, where I live. And if you're familiar with Lower Manhattan, a lot of bankers, a lot of lawyers at the time. And I remember being on the soccer field with one of my kids talking to another dad. And I think he was a lawyer for securitizations. And suddenly he's like telling me how he securitized some data center deal. And I was like, wait, what? Like, you mean like you're in data centers? He's like, no. I'm not in data centers. I just did this giant transaction related to securitizing a bunch of data centers. And at that point, I asked him, like, have you ever been in a data center? He's like, no, and I was like, wait, what's going on? The big money was coming for our industry. It was getting really scaled. And I thought, wow, now finally we have an interesting opportunity to change the way infrastructure is working if we can take this large pool of capital that was starting to come up. It wasn't just going to be capital owned by Amazon or Microsoft. Suddenly there was these third-party sources of capital that were interested in our space. And so I decided that and with another, I must be the Battery Park City soccer field, mafia. One of my other neighbors was a gentleman named Dan Kahn, who had started the CNCF. And we started talking about this thing called Kubernetes. And, there was going to be this, Alex Polvey was a friend of mine. He had started CoreOS. He had previously sold a business in the rack space. And I was like, wait, you mean Linux developers are going to be able to move workload anywhere they want without VMware? And that just said, well, if people can move workload across infrastructure, this is going to really change, that plus this kind of concept of capital would really change the landscape. And so I thought, well, what I know how to do really well is I know how to do the plumbing, the picks and the shovels for turning on and off computers and turning on and off networks. And so I thought, well, what if we could do that regardless of what the computer was? Was it an ARM server or an Intel server? You remember at the time, it was only Intel, right? AMD had not risen from the Phoenix, and ARM was basically only on your mobile. And I said, wait, there's going to be specialized computers that do different things, And now suddenly you're going to have workload that can be portable. Well, somebody's going to need it good at turning on and off the computers, normalizing them, doing kind of this lifecycle management for cloud, no matter what the computer was. I thought also no matter who owned the computer. Well, what if the hosting company didn't have to own it? What if it was an asset manager or somebody else or a data center company? And also no matter, kind of what software you ran on it. It didn't have to be some verticalized stack that was more portable with this kind of concept of cloud native computing. And so we started a business called Packet, which was to provide that fundamental automation for computers, no matter what it was, where it was, or what you ran on it. And it was quite a ride. We raised some capital. This time around, we decided to go venture-based because we really wanted to invest in product. It took us, we had done a seed round of friends and family and kind of got $1 million or $2 million and proved that we could make it work and, things like that. And then after 52 no's, SoftBank agreed to lead our Series A. And so that was...
And what year was that?
That was 2000, I guess probably late 2015 is when they came in on the A, along with Michael Dell through Deltec Capital. And it was great. Yeah, they really believed in ARM. I didn't know it at the time, but they were just buying ARM. And we were the only company on the internet automating ARM servers. So they were pretty janky at the time. The tool chains didn't work, but we had to use kind of our infrastructure capability plus our community around open source software to get builds of Linux and Golang and everything working on ARM. We sponsored the Linux Foundation to help all of Kubernetes and the CNCF to be able to support different architectures like RISC-V and ARM and Power and whatnot. And so it was a good run.
So Packet is like a software layer in between Kubernetes and the hardware.
What we were is just giving the concept to developer accessible bare metal. So machines, whether it was a Raspberry Pi or an ARM server, a big Intel server, or an Nvidia box, we wanted it to be controllable via an API. And we felt that developers needed constructs that were not the same as what sysadmins need. Sysadmins would get on console and look at the BIOS boot up. What we built is all the automation so that they could have a REST API and say, boot up this physical hardware, whether it's ARM or Intel, set these kinds of parameters, pixie boot into this operating system that I defined because maybe I built my own operating system, and then get out of my way after that. And so that's what we did. Hardware, automation, and life cycling.
And what was the relationship between what you were doing in Packet and VMware?
Well, VMware was a layer on top of us.
Okay.
We were all the bring up that everybody didn't really want to deal with. After the machine booted into its operating system, we left people to their own devices.
Okay, so Packet
2014 is when we started.
2014 to 2020.
2020.
To 2020.
Yeah.
When did you sell?
March 2nd, 2020.
Wow.
Yeah. And so how that goes is basically we had raised capital. We'd brought in some more money in our Series B. And then we had started to form deep relationship with the real estate companies because everybody was starting to realize that automating physical infrastructure within their buildings was going to be pretty important.
So you're going to the real estate company, which is a hosting company, but not a hyperscaler.
Even more basic than that, the data center businesses.
The data center businesses. And saying, I can make it so that all of the people who are bringing machines in, that it's easy to run. Like, what's the value prop to the real estate?
I mean, there was two. There was one basically saying your users no longer want to come to your data centers. They just want to access them. And so how are you going to address that? You must give them a portal. You must give them an API. You must give them idempotent interfaces so that you could ask a question with a program instead of a human. In order to do that, you could do two things. Number one, you could provide them those things, and I called it automated colocation. You could provide them bare metal hardware with the lowest fundamental things, but with some sort of automated interface to turn it on and off and put it into the right network and things like that. Or you could offer them software and allow that to happen to their machines. Unfortunately, I would say the industry wasn't really at the place where we were able to succeed with the latter. We had a product that did that. We did it only for the largest customers, including people like Sprint and some others who needed to put very specialized infrastructure in very special places, but they wanted this automation layer. Unfortunately, I don't think it took off nearly as much as it could. We were probably a little ahead of our time and maybe not good enough at it.
So most of it was you were buying
Yeah.
the full box.
Yeah.
From who?
I mean, from original manufacturers, ODMs, from OEMs like, Dell and whatnot. And then in certain cases, the customer would buy them to our specs and we would automate it for them. So changing that kind of capital stack a little bit.
So you sell the Equinix, and what was the value prop to them?
Well, Equinix is, as a business, Equinix is the world's largest operator of interconnected colocations. So they have 250 or 300 buildings all around the world that house over 10,000 customers. I think it's something like 5,000 networks that interconnect at their facilities. And what they do is they basically offer space, power, and cooling, as well as either a rack or a cage-based place to put your own equipment. The real value is offering an interconnection product that allows you to connect from, say, your enterprise assets like your router sitting in an Equinix location to Amazon. As Amazon is not interested in having people run cables into their data centers. So they would meet you at Equinix. And in fact, Equinix started in 1998 by a gentleman named Jay Adelson, and it stands for Equality and Neutrality in the Internet Exchange. And it was the first IX where people would come and exchange traffic between, say, a telco like AT&T and content like AOL. At the time, AT&T was like, you bring everything to me. And AOL was like, wait, I can't do that because then I need to go to everybody. And AT&T was saying, how would I reach all the content? And so Equinix was formed first as Palo Alto Internet Exchange, the first kind of neutral places where carriers and content could come together. And that continues to be their business today. Why Equinix bought Packet, I think, was strategically they were trying to move to address, number one, their platform had gotten very big. Just to give a little bit of concept here, beyond 250, 300 buildings, it's in like 65 markets in 40 countries. The concept that you're going to be able to go and put infrastructure in Melbourne and also in Sao Paulo is just very, very big, even for their most sophisticated customers. Being able to put infrastructure everywhere on your own was just becoming so difficult because the world had gotten so distributed. Yeah. And then the other was just a user preference. People wanted to move faster. And, I would say from my experience, the average time, this is not specific to Equinix, but all across the world, if you want to get your own infrastructure and put it in a co-location facility in Sydney, from the time you say, I want to do that, to the time that you are using it is probably somewhere between 8 and 12 months. And that's a long time.
Yep.
And so they were trying to figure out how could we remove friction on a global basis and provide more automation for our customers without competing, because remember their name, equality and neutrality, they're a neutral player. So how can they provide more convenience and less friction without competing with their public cloud customers, who are some of their biggest customers, their other service providers? And the answer was effectively do hardware as a service. Partner with the OEMs and the silicon partners and bring the expertise internally to automate and deliver hardware throughout their global footprint.
In my mind, I had thought of it as, well, I've got some companies that really want to be more in control of their cloud. They don't use AWS. They use an Equinix.
Instead of building their own data center.
Yeah. It sounds like more often than not, it's, well, I'm using AWS, but I've got a ton of my own information I need to get to AWS and get out of AWS. And it's AWS doesn't want to actually have fiber from me, say Coca-Cola, going into the AWS data center.
Correct. But more likely, Coca-Cola also buys infrastructure from Azure, has their own private data center, has a giant Oracle Exadatabase somewhere else, and has just a confluent of systems that all need to interconnect somewhere. So what you'll find is large percentage of the internet's traffic goes through Equinix. So we're talking well over 50% of the internet's traffic and most of the private interconnection. And so you go there to kind of meet your different partners in a neutral space. So maybe it's AWS connections, but maybe it's also your wireless provider. Maybe it's your corporate network. Maybe it's Zscaler for their firewall service. You're connecting with a lot of different networks at Equinix usually. And you're probably putting some infrastructure there I would say in majority, it would be network infrastructure primarily. Then it became storage. Your data sits in between all the clouds, not at the cloud. So a big use case would be your NetApp or your Exadata data warehouse or some sort of other, kind of thing, because it'd be too expensive to put it in one cloud and then also move it to the other and then copy it there. So you put it in the middle and just get low cost interconnection between all of them. And then started to become hybrid cloud, which is workload moving between them for accessing, the public clouds that evolved, over the last decade, not from simple infrastructure companies, but actually application providers. They're providing BigQuery and, Redshift. That's a very different layer. So some teams within Coca-Cola are using Redshift, some are using BigQuery. How do you make those talk and manage your, firewalls and networks and things like that?
So I became an entrepreneur in 2010. A lot of startups, you still just live just in the cloud, with the hyperscalers.
Yes.
Today, this topic of sort of compute capacity, I would just love to hear if you take a 10,000 foot view and even maybe spending a moment on AI about what's happening right now from your perspective.
Well, there's a great quote, so I'm just going to steal it from, I believe, gentleman's Alan Key. And he said, there's never been a more interesting time to be in boring infrastructure. And the fact of the matter is, I think your story of kind of relying upon or assuming unfettered access to effectively low cost, what I'm going to call commodity infrastructure, is still true, which is if you're in the business for commodity infrastructure, it is very accessible through public cloud interfaces, right? You can get it kind of where you want it, when you want it, on a consumptive basis without having to do a whole lot. It's relatively efficient and pretty price competitive. And that works almost all the time, except for when you're not trying to do something commodity, right? And we've been in a trend for the past 10 or 20 years. I like to call it from a data center architecture. We moved from mainframes to client server. And then after that, we've just kind of scaled it out, right? With it doesn't really matter. We just need more instances or more of it, or if the chips got faster and the network got a little faster from 10 gig to 100 gig. And, suddenly we just had this commodity access of x86 where we ran everything. And we solved a lot of the problems with software. Yeah. Like orchestrators like Kubernetes or, distributed memory systems like databases or whatnot, and consensus algorithms and load balancers and yada, yada. But now suddenly we've made an architectural shift into something where the computational asset is no longer a commodity. It is the advantage. It is the requirement. And software is an important and critical part, but they have to be highly integrated. Your software and your hardware is no longer I'm going to run this generative AI program on whatever infrastructure happens to be available, which you could completely do with an Nginx web server. x86, ARM, big, small, I just might need more of them or less of them. But now it is completely not possible, right? So you must have highly tuned software with highly, specific hardware. And so suddenly hardware matters again. Right? And I would say, unfortunately, I think they took our phones away, but that was always my good example was, hardware is a commodity, except for when you use it all day long and you need the battery to last for 18 hours and you stare at it all the time like your iPhone. It's completely not commodity. What happens when Apple gets on stage? The first thing they do is the new Bionic something or other chip. They don't talk about anything else. They talk about the hardware. When workload becomes so big and so important, you optimize the hardware around the software, not the other way around. And I think that's just the age we're starting to move into, where that's become generally needed by most enterprises. Hence why, well, where's my hardware? How do I get it? Where would it go? How do I power it? Who's going to turn it on for me? How are we going to finance it? All these problems are starting to come around, which are not new. They just mattered to only a few people. I'm going to call them scaled service providers, and now they're mattering a lot more to enterprises.
And so, what do you see happening right now as this is starting to matter? I mean, I know you've got a network now of over 20 years building in this world. Take us down to what are some of the specific things going on as people are trying to, capitalize on how important hardware is at this moment?
They're kind of surprised, right? A very common thing I've heard recently from companies who have acquired significant amount of capital to put a significant amount of infrastructure into market to do the thing that they want to do is going and saying, well, great, I just need a significant amount of data center capacity, power, cooling, and space, to which the industry kind of laughs and says, well, that's not available. We don't have any for you. In fact, we're going to get some more in 2024 or 2025. Would you like to sign up for a 10-year lease now? And so that's a very big disconnect from the public cloud experience where you can kind of just get more whatever you wanted, right? And so I think like the onion is getting peeled back on some of the capacity challenges. AI infrastructure in general is extremely power intensive, but the way that people are going about this right now is really requires a lot more resources than what we have available. And so just the pure concept of the physical build and needing this infrastructure, there's a delay factor, and there's also some just true hard requirements that I think most people aren't used to having to touch. So that's one, is just the capacity issues and the related time cycles for accessing those. I think the second one is kind of exposing the dirty little secret. If you were to go and Google on the internet, use the Googles to try and find a great open source software suite, like you could probably find really good open source software for many of your use cases if you're building a new SaaS application. And if not, you could probably find some SaaS services to help you plug together your auth with your database, with your this, with your that. If you were to go do the same thing for how to automate and bring up my millions and millions of dollars of data center infrastructure, you would find basically nothing, right? And that's because most people have not valued this part. It's been, kind of captive within a few cloud service providers and others, and most people just didn't care about how to automate InfiniBand switches or, lifecycle BIOS and firmware related to all the PCIe lanes that you have. Like people just didn't need to know about that stuff. And that's the tool chain that is actually missing for a lot of people to be able to take, hey, listen, I got capacity, I got my things. Now, how do I operationalize that and make it accessible to my user who might be an engineer or developer who needs to, start turning on the computers? And so that is a gap right now, a tool chain gap, which I know people are working on solving, but is still like surprisingly like, oh, I thought that'd be a solved problem. And it still feels a lot like 2001 to me. The overarching sustainability aspects of this world, it's extremely energy intensive, extremely resource intensive, like water for cooling. Oftentimes you're putting all this infrastructure in a market only to use it for 1 to 2 years. Before what? You throw it all away? We don't even have good recycling systems. And now what didn't happen, and maybe this is different in your dinner table, but at my dinner table with my mom up in Marlborough, Vermont, she wouldn't ask me about how's the internet infrastructure doing today or tell me more about chips. But over the past 2 or 3 years, that's changed. Suddenly, it's become pop culture. The chip capacity issues that everybody was dealing with. Nobody's like, my dad was like, I can't get a new car because they don't have chips. And then AI is suddenly like, wow, what's going on with all this AI stuff? That is different than a few years ago, where suddenly now there's this general awareness, which is also leaked into, well, where do all those servers go? Or do I want those in my backyard? Or what's all those big buildings down here in Ashburn doing? Why do they keep building more power lines? And so now we've started to see regulation and public awareness around an industry that, is needing to evolve quite a bit to be able to really meet the demands that we have and be sustainable.
So try to give us like an image of just how
big,
energy intensive this is, and like where we're heading with AI and how big it could get.
Well, some estimates are, first off, we have a lot of data center capacity in the world today. Thousands of data centers, but think millions of square feet, size of huge football buildings with millions of servers in them. That's hundreds of megawatts of power, enough to power tens of thousands or hundreds of thousands of homes, creating heat, which means you're using air conditioning to generally air-based cooling systems to evaporate water. So millions of gallons of fresh water a day in some of the most arid climates, which are some of the best to operate data centers in. And they have to work all the time, 24/7. So then think generators and backup power and everything that goes into that. Okay. Some people's estimates is that we're going to have to create to meet the demand that's coming in this AI wave, like 4 to 5 times more data center infrastructure over the next 5 years than we have total combined already today, which is just mind-boggling to me. I could see why when you play the math, because AI infrastructure itself currently is orders of magnitude more power intensive than the workload that we're doing today. And people are figuring out how to do so much of this work. And so the infrastructure demands are crazy if you just look at it literally. Now, I happen to believe that there's going to be a thing called innovation that happens. And so I don't believe that we're just going to work on a straight line towards, from 100 megawatt to a gigawatt to 10 gigawatts of capacity just to do these things. I think we might have step functions in terms of efficiency, that there's enough people focused on the problem that will have innovative solutions to waterless data centers, I actually think we'll see them as opportunities for baseline load for some of our renewable initiatives like hydrogen, where a data center could be the number one customer of a hydrogen, generation capacity, like by far, which would, I think, be transformative for some of our energy infrastructure. So I think that that's going to be the interesting shift. If we take it from a pure just like, well, we have to build more, into, well, how do we solve this?
In terms of the tax, how much of it is power, water, the raw materials for the chips themselves? Like is there any like really big cost in there, or is it spread out?
Well, I read a statistic, this was several years ago, but something like the analysis that I think one of Intel or somebody had done was the carbon intensity of let's just take a server, over its entire lifetime, which might be 6 or 7 years. 60 to 70% of the carbon intensity of the server is making the server, refining the metals, digging them up, processes, technology, fabs, supply chain, parts, copper, you name it, right? 20% of the carbon intensity was running it for its whole life, and 10% was getting rid of it somehow. That the majority is in making it. So we have a couple of different options here, right? And that's not counting, I think, the full load of the data center around it, the energy impact, the water impact as well. But I think we have a few options. I grew up in California in the 80s, reduce, reuse, recycle, right? I'm not sure we're going on the reduction thing right now. I think we're going on the expansion. But we definitely need to figure out how we extend the life of these assets. How do we reuse more of the components? Like, why are we throwing away so much copper from the power supplies every time we want to upgrade the chip? Well, because the power supplies are built in the server and we just throw the server out. Why wouldn't we make it modular so we can upgrade things over time and keep all the sheet metal and the chips and whatnot, right? So there's a lot of options where we can start to, especially at the scale that we're all discussing, start to reuse large portions of our infrastructure.
Who's incentivized to do that type of sort of circular manufacturing, supply chain, et cetera, to make it such that that's going to happen?
Unfortunately, right now, not enough people. Chip companies get paid when they sell chips, and server companies get paid when they sell servers. And data center companies kind of see it as a burden. Like, why do I have to deal with all your stuff? And so I think it's up to new business models that come in play that see circularity as their advantage, where it's a lot cheaper for them to get back the infrastructure and make it into something new than to dig up new ones, dig up new stuff and make all new things. I think technology companies and the people who sell into the supply chain are going to need financial incentives to want to, number one, see their asset live as long as possible because it could generate them more money. I like to think of like if Intel could make a penny per core for every hour that their Intel chip was being used, they would probably work a lot harder on optimizing software to work on the Intel chip over time versus just for their next generation chip, right? So instead of ticking and talking and trying to sell the next H200 or H300, maybe you worked on optimizing the thing against the old chip, right? Like there would be incentives there. There's not incentives right now. I think that part of this will be because it will be a better business model for somebody to come in with a better answer. I don't think customers love the idea of throwing everything away every few years, or they want the best, or they might need the best. But what does that really look like for them? And right now, I think there's not a lot of flexibility in the model. And frankly, the other thing is we're going to see regulation. It's too big of an industry and too important to the world. And so we'll start to see more rules.
I'll share a few data points with you that have come to mind recently. One is the story of MosaicML, which I think I, like a lot of people, have tried to like wrap my head around the acquisition there. They got to 30 million in revenue in under 18 months. So it's like, how did that happen? Like, what was actually going on? And I recently learned that the CEO Naveen had the foresight to understand what was happening and basically reserved $200 million worth of GPUs.
So
and
great
just,
arbitrage.
Yeah, just totally knew the moment of what was coming
Right.
and had access at the exact moment that nobody had access.
So $30 million is cheap.
Fast. It's so fast. The various layers of these new cloud providers in terms of like the Neo GPU clouds, Lambda Labs, CoreWeave, Modular, et cetera, the sort of inference as a service companies together, Fireworks. There's a lot of startup activity, which must be really new for you in a sense, in terms of like,
so.
This is like, you've been living in this world for a long time and it hasn't been like the place that everyone wants to like get in on the action. Do you like that? Is it annoying?
I mean, I think it's great.
Good. Okay, good.
It's definitely very different. And that's why I used that Alan Key quote earlier about infrastructure, being so exciting, right? It's the stuff that actually, and what excites me is not just that, hey, this stuff is pretty neat, right? It's pretty impressive what, I think our industry can accomplish. But there's two things that really excite me. Number one, without hardware innovation, there's no way you get 1,000 times or 10,000 or 100,000 times better, faster, cheaper, more efficient. Mm-hmm. That's just unbelievable when you take and optimize hardware around a workload, what you can do. Mm-hmm. It's incredible. Mm-hmm. And I think unleashing that to more people is going to be great for our world, for our resources, for the sustainability of our kind of technology-based culture. Like, we are going to need to optimize the heck out of this stuff. What I've always loved about the world of internet infrastructure is what drew me in at the very beginning was around Linux. I love the open source and community-based aspects. There's so much work to be done, but you have to make it go together. It doesn't do you any good if you design a data center, but you can't take servers from Dell and the chips don't fit in the server. Mm-hmm. We have to work together. And I love that. It's not like a winner take all. There's so much work to be done. It's such a big industry to accomplish, and we have to actually interoperate at some point. So I like the community aspect of it.
Yeah, and so I know you have some ideas on this front around the sort of where open source can play in all this. Is there a Linux level innovation that could come right now?
Well, there's been some work related to open ISAs like RISC-V and whatnot, if you're familiar. So there's open source, which is coming around that. But then there's two projects, one which was started by Facebook and Microsoft called Open Compute, which is around innovation on hardware, on the power supplies, the data center infrastructure and related. And there's another one, which I ran for a while, called SSIA, Sustainable Scalable Infrastructure Association. It's part of the Linux Foundation. And we just focus on interoperability between servers and rack level infrastructure for power, for liquid cooling, and for recyclability. So I think there are some efforts, and luckily we're seeing such a shift. 3 years ago, 4 years ago, it was really hard to get the attention of chip companies and data center companies to pay attention. They're like, well, why do we need to work on this? Kind of a solved problem. It just works. I'm not really sure how it works, but the data centers are full and all the servers got sold, so it must be fine. Now you're starting to see this intense interest in, we're starting to reach the thermal limits of how we can do this. We're starting to not be able to get enough power. The cooling doesn't work anymore because we've just pushed the limit. Nvidia has been a big part of that, but also Intel and AMD, they're now all interested in different form factors, different cooling methodologies, different ways to maintain this infrastructure, which is, in my opinion, just a welcome sea change. I think that the other side is getting the data center operators together and figuring out how we can interoperate, because I do believe that infrastructure is going to get more integrated, if that makes any sense. Mm-hmm. The best analogy, and I wasn't a thinking human at the time, but the best analogy I can make is we're almost moving back to a mainframe style experience. We've got a highly integrated hardware environment that's starting to emerge that is not just random pizza boxes that show up in a rack. And so I think we might end up with more integrated rack level or pod level infrastructures instead of the kind of, I'm going to call it lazy 19-inch rack options that we have today. I call them lazy not because people are lazy. I call them lazy because you don't have to think about them in advance.
Yeah.
If it fits in a 19-inch rack, you could put it in a data center. That is no longer becoming the case.
Let me share with you my kind of mental image about part of why this is needed. For these compute intensive jobs around AI, the amount of memory and the amount of compute that's needed to run a job is such that you need it on a ton of different computers. Like you cannot put 1 trillion parameters on a chip or even on one rack. It needs to like networking within the data center.
Yes.
We're talking about moving data around in a strategic way or in a way that enables a particular computation to take place. It's finding data, bringing it to the right place to run some math on it, moving some more data there. Any additions or like, Brian, think about it like this, clarifications?
Well, one of the common misconceptions with the world of data center infrastructure has been, okay, we have to have more computers. That's fine. They're getting hotter. Yeah. Why? Because we've moved from, 10 nanometer to 5 to 3. We've gone from 1 layer to 3D layers.
Actually, why does that make them get hotter?
Well, you're fitting more transistors in the same amount of space.
Okay, yeah.
And then you have to put power through those, right? And then you're also stacking them.
So it's like the transistor, whether it's on a 16, 10, or 4, is the same amount of power.
Well, I'm not probably smart enough on the physics, but I do know that the more transistors, eventually more power. Maybe they're slightly more efficient at 5 nanometers than 10, but the basic thing is more juice through it, more transistors per millimeter, and also stacking it 3D, right? So instead of just 1 layer, you've got multiple layers. That's all just creating more and more power, right? Okay, fine. So we know that about a computer like a DGX or a server with a bunch of H200s in it, yeah? The challenge that people have started to realize is that, oh, wait, I need to move the data around. Because like if these things are just sitting there, how do I get enough data into those cards to process them fast enough, right? So that's your big expensive commodity. You got to shuttle the data in as quickly as you can. So then that relies upon the network that sits within the rack, right? Or the network that sits to join the racks together. And a friend of mine, he used to run a company called Cavium, and this sold to Marvell, but he was a big Ethernet guy. And he's like, never bet against Ethernet. It's good enough and cheap, right? And that's kind of been the methodology for a while. It's like 1 gig to 10 gig, 10 gig to 100 gig, 100 gig to 400 gig. Cheap, right? Cheap and easy. The challenge is like that was working in a world where you could spray and pray your workload in a scale out manner.
Right.
But now you got to like really, really carefully at the right timing move the data to these chips. And so now you need a super high performant, very lossless network. And that's why Nvidia bought Mellanox, for example, because it knew that it had to invest in that. The misconception, the infrastructure that I ran into in the data center world is, oh, let's say I have 10 kilowatt racks. I can put 2 machines in it. Well, I'll just get 10 racks and spread them in the data center, and that will be a good answer. Challenge is your networking component to connect those 10 networks is so expensive. What people end up doing is they want to put all the systems in one rack. And so now you have 70 kilowatt racks or 100 kilowatt racks. So we're getting denser on the rack level because the networking equipment is so expensive. You have to create these line rate mesh networks to move the data between the clusters. So I think there will be some innovations there. For example, why do we have racks that are only this tall? Why don't go taller? Like, why do we have racks that are only this wide? Now we can start to think, wait, maybe there's a better way for us to combine the chips and the data and the network together. Hence why I got to the more integrated systems concept. And then also I think we'll see new protocols, for example, like coherent interconnect and whatnot, different ways for people to improve the networking outside of the box. How do you make more boxes? By the way, they're just boxes because they're convenient form factors, right? Do they really need to be that way?
We'll probably end up in a place where the AI models how they should actually be designed.
Right. I mean, we're probably doing that to some degree right now.
Someone must be.
Somebody's doing that.
One thing that comes to mind, there's this moment where an industry has a lot of legacy knowledge that's incredibly valuable, that's essential for running the industry. heavy manufacturing is like this. Military stuff is like
Right.
this. And then you,
Aircraft manufacturing.
yeah. But then you get a moment of a sort of new wave of interest. People who only know a certain sort of sliver of the discipline, but have, other expertise or sort of entrepreneurial sort of drive to innovate. What's going to happen? Is there going to be a culture clash here between like the people that have been doing this for a long time and new people? Is that, do you see that kind of thing taking place?
I mean, to some degree, I definitely see a generational gap happening, right? There's just not enough, and this has been kind of an alarm bell in our industry for a while. There's just not enough people who are aware and invested and entering the world of the lower layers of the stack, right? To even be able to innovate on it. And one of the funniest things, I tried to launch it when we were at Equinix, we never fully got it. Partly pandemic, partly otherwise. We don't let anybody into our data centers. I was trying to bring my kids' 6th grade class, but we wouldn't allow them in. We won't allow them in because they're not customers. They don't have IDs. We need to do hand badges. Like literally we couldn't get a tour done. I was like, well, that's probably unlikely that they will be interested in working in our industry if they can't even see it, if they can't go anywhere near it. And I think that's one of the great successes of the data center and cloud industry is we've made it so invisible. People don't need to worry about it. At the same time, we haven't opened it to allow new people to come and experiment. And it's also the double-edged sword of internet infrastructure, data centers, power, cooling. You don't just fiddle around. These are really big, expensive things to do. And there's not a lot of venture capital people who say, yeah, we should build a new battery system for data centers and try to invest a whole bunch of money to see if that's going to be a good idea. There's just not, it's not been the de rigueur, as it were. I think that's changing, which is good because people are saying, wow, this is really critical and also really interesting, and there's a lot to do. So my hope would be that we'll see more companies and people interested in the space, or at least aware that there are even challenges around it. I would guess probably a whole wave of entrepreneurs know way more about data centers, power, internet infrastructure, racks, et cetera, than they knew 18 months ago.
Definitely.
And as such, they're probably noodling on, what could it be different? How could we improve that?
We made the investment in Etched, and I remember earlier on joining a customer discovery call with a network provider, not one of the hyperscalers, but a big company. And all of a sudden watching Gavin, the CEO, realize the different power requirements and expectations that they had versus someone at a hyperscaler versus someone else. And that was going to be very important in terms of architecting the thing about what it would be able to do. And it goes back to this, well, how many transistors are here and how much power they're going to need to be receiving in order to be able to run it. So for sure there are more, and Gavin's 21. He's a bit of an outlier, but I think also there's certainly more.
Which is great. And I think that we need them in the industry. There's more work than to be done, and there's more problems to be solved than people to solve them. So luckily, and it's non-trivial. I mean, some statistics say that the data center industry itself is, slated to be 4 to 5% of global power consumption.
Wow. It's
not small. I mean, what's cement and steel are 9 or 10% of carbon impacts, and electricity is probably a pretty good corollary to that. So it's a large part of our societal infrastructure. And I guarantee when the internet doesn't work because a data center goes down in US East, everybody in this at least in this country knows about it, right? They might not know what actually happened, but they are definitely impacted.
Definitely not. What are some companies that you're really excited about right now?
Well, I have different layers. So I'm super interested in the fundamental technology of sustainable data centers. So I'm a big fan of a company called Edge Cloud Link. Yuval Bachar is working on hydrogen economy for data centers. He's got a 1 megawatt test facility that I went and visited in the Valley 2 months ago. It's awesome. Its only byproduct is fully desalinated water.
Wow.
It's amazing. I'm interested in all companies doing what I'm going to call like cloud style operations. It's hard to run infrastructure. It's a service business, right? Things break all the time. I always love it. Somebody told me the other day, culturally, it just set off this, itchy, thing in the back of my head. because this person was kind of saying, well, you should just make sure to have it not break. Like, and I was like, no. That's just culturally wrong. You should make sure that you know it's gonna break. This stuff breaks all the time. And the real world infrastructure companies who know how to run these things and build culture of service around that. I was listening to a podcast of Danny Meyer recently, Union Square Cafe. And he just goes into the culture of service. Like, restaurants are not a food business, they're a service business, right? And how to create those connections with your customers and make them feel comfortable. And that's the same thing in service providers. It's about trust. And so teams that can build and operate fundamental infrastructure, platforms, to me, I'm very excited about. So I'm very interested in what I'm going to call the specialized clouds that are emerging today, whether they're in databases or in PaaS or in distributed infrastructure is very interesting to me. And then I'm kind of interested in the open source reinvention. I feel that we're turning a page. I've been an awesome bystander to watch the growth of several open source companies like Grafana. Has been an awesome ride, and to watch them, kind of grow within the industry. But I still think that we're just starting to see a class of companies that are born in a kind of cloud first model with open source as a distribution. And like Post-Hog would be a great example of that, right? Somebody who's got open source at their core, but started with a sign up page on day one. And there's a lot of companies who have transitioned to that. Like Mongo transitioned from we had years and years and years of culturally distributing software and charging people for support. And then we built Atlas. Okay. And they've now transitioned primarily to a database cloud company. But I'm excited about a class of companies that are coming with open source at their core or as part of their DNA, but are cloud operators from the beginning. It kind of yields the best of like a decent economic model with finding your product fit and customer really quickly.
And the intersection of that with these sort of hardcore infrastructure challenges.
I mean, that's personally a place that I just love to swim. So,
do you think Nvidia, they're now valued more than Google?
Right.
Their revenue this year will be less than Google's free cash flow.
Right.
But they're valued more than Google today.
Sure.
So what do you think is going to happen there? Is Nvidia going to keep dominating? There are a lot of people who are saying we're frustrated with Nvidia in one way or another. Sure. Whether it's like the AMDs, Intels of the world, new startups, cloud providers. Can they maintain this position? Do you have a point of view on that?
I mean, I wouldn't bet against Jensen. I mean, a pretty incredible and tenacious leader. Right. And one thing I can say about spending time with Nvidia over the years is they don't just talk about moving fast. They really do. It's like built into that. Now, can they keep that up at this pace where they're a big company now? We'll see. But I've been impressed to date, right? As a founder-led business, I mean, Jensen is all in and very involved. And that business is really all about moving fast. And so I wouldn't bet against it. And I believe that the shift that we have not yet seen, but are going to see, is that I haven't heard anybody say, oh my God, I just loved buying all these GPUs. They want to do something with them, right? It's a little bit interesting to me that there's so much built in. I can see why. It's generating they're in a very dominant market position. They've got a lot of advantages. They've got some really good moats, that are sitting there. But in reality, nobody really wants to buy GPUs. They want what those things can do. And so the question I've always wanted is okay, how does a company like Nvidia, which is basically selling picks and shovels, compete against an outcomes-oriented business, right? Where Google will move with outcomes. They're don't worry about buying GPUs. Just ask the question that you want answered. And that is maybe it's not Google who does it. Maybe it's a new class of companies that come out and say, hey, we can provide you the outcome, which I think is what most enterprises want to pay for. They want that faster. Now, this is the only way they can get it. And so they're investing and buying and learning and whatnot. But I think outcomes people will over time pay more for. And the question will be, I think, can other companies adapt? Will Nvidia be able to move towards that, either by offering its own service or through a network of new clouds or new outcomes or whatnot that enable that? Or will some of the other chip companies move there faster?
Yeah, I've spoken to a number of founders who are all working on portability between hardwares in one way or another, which is funny because all the ones I'm talking about are specifically focused on the sort of the movement from PyTorch to Silicon.
Right.
And how do you make the sort of kernel ops either irrelevant or so streamlined that you don't need a kernel engineer.
What's the trick in computer science? Just one more, abstraction layer, right? Or like something like, I don't know the phrase, but something to that extent. One more layer of indirection. So you need just another abstraction layer that makes it work, right? And so I think that's pretty common. And most people are like, oh my God, why would we be totally tied into the CUDA thing when we could work for both CUDA and PyTorch? We'll have to figure out an abstraction layer that makes that work and compile against both and test them automatically and do whatever, right? And so I think that's definitely one of the areas of opportunities. The developers are just going to attack things and create appropriate abstractions so that they're not tied into one, or they can optimize where they want, right? But I think the hardest part, and this is something we focused a lot in at Packet, we used to throw a conference right outside of AWS reInvent in the desert, like in Las Vegas in a parking lot called IFX for infrastructure. Mm-hmm. And we had a hardware petting zoo. It was really cool. We get all the hardware manufacturers to bring their stuff and we let people just pet the hardware.
And they would bring it.
Oh yeah.
Yeah.
Oh, we had 5G base stations and GPUs and weirdo routers. It was really fun. But think of it as Burning Man for hardware nerds.
Yeah.
Probably a good overlap in those two communities. But we have that challenge right now, which is we don't, even for engineering teams or open source ecosystems to be able to work on providing nice interfaces, different libraries, abstraction layers, portability, optimizations, they would need access to this hardware. Both of it, all of it. They would need this new providers, they would need access to etched stuff. They would need access to AMD's new MI300s. They would need access to all these things without abstractions so that they could do that work. And right now, I think we just have a real capacity, lack of available fundamental access, because the bar is very high in order to get to it. Now, I hope that will come down. I think it will in the coming 6, 12, 18 months. And there'll be more, and that will enable folks to do this software work. Because I have seen some pretty incredible stuff. This is very similar to what I lived through when we got ARM working. And we actually worked with ARM to sponsor free unlimited build infrastructure for open source software. And we had, I think, 300 or 400 different software packages building CI runners against fundamental ARM servers in 2015 and 16. And that effectively created the foundation for Graviton to be around. Because without it, none of your software tool chain would work. Mm-hmm. We need something similar for this fundamental infrastructure on ML.
So I want to hear just a little bit more Graviton. Can you just share, first of all, for the uninitiated, what is Graviton?
Yeah, sure. So Graviton,
myself included.
Graviton is Amazon's ARM-based EC2 instances. Or a family of instances that they have at this point. So ARM is a developer of IP. So they don't make chips, they just license a runtime. So x86 would be Intel's, which also AMD has a license to x86. Go back and read on it, the Minuteman missile, and find out how they got a license to x86 forever. But then ARM64, which would be the kind of runtime or ISA that people have developed software for, primarily in mobile devices, but over the past 5 or 6 years, server infrastructure. When we first came with Packet, what we were trying to do was say, hey, there wasn't a competitive environment in CPUs at the time. It was just Intel. Mm-hmm. AMD was really not there yet. And there was this kind of is Power going to come? Is ARM64 going to be able to show up? Is RISC-V going to be able to happen? But when you would go to and try and run it, it was almost like a science project. You had to compile from source and build every part of your tool chain. Mm-hmm. I mean, that's if you got your operating system booted and then you wanted to run some basic Node app. You would have to literally compile Nginx against ARM64 and compile your database memcache and compile everything. And so we offered infrastructure available, bare metal ARM64 infrastructure, and went out and solicited and called friends who were maintainers of Golang and maintainers of Python and maintainers of all the different stuff to start to build the binary daily CIs of the kind of software ecosystem. And that kind of enabled, general use. And the big tipping point wasn't actually Amazon, it was Apple, right? Which is suddenly you got a nice MacBook M1 Air that was fully ARM, and they did a lot of work to have natively compiled ARM infrastructure
and
software.
Was Packet involved there too?
We were working with them and Microsoft, because Microsoft, you remember, had Surface, and we're making all of Windows in the tool chain build on ARM. And so, we worked with them and Qualcomm at the time to make the software ecosystem. And that was just a multi-year long effort of slowly getting dozens and then hundreds of open source software tool chains to build and compile ARM binaries every day. Well, so the point though is that if we're going to see a ecosystem of multiple ML software stacks against hardware that is much more different than, say, ARM64 versus x86, we're going to have that available infrastructure, and just even the software build times, the CI systems, the related, to produce the tool chains and then optimize them. Right? It's not just, can you make it, like, what was the one big problems with ARM? Oh, you could compile it. It just ran like crap because nobody had ever tested. Oh, does it do this thing? Oh, it turns out that acts differently on this, So even those edge cases, that's what we're going to have to get at. But then I'm very confident that if you give access to that infrastructure, which I believe will happen over the coming 6-12 months, the software ecosystems will eat it up. And they're already multi-arch right now, which is great. So I think doing these different frameworks could really be, could be a place of innovation. I think the bar has gotten really high related to the commercial experience. So one of the things that we didn't touch on here, and a general thesis I have, is that more diversity in software and hardware, in technology in general, is good. That creates more innovation. We'll see better outcomes if more people can have the petri dish. Okay? Challenge is hyperscale. There's only a few. There's 3 real big hyperscale ecosystems, and they're much more than just technology ecosystems. They're also ways of doing business, commercial terms, concepts of it works everywhere, things like utilization and usage. And I believe that we have an opportunity to move past seeing, do you have a data privacy officer for the European Union on staff to do the thing as the barrier, and maybe even have things like a Better Business Bureau of cloud service providers, or a consortium that started to provide portable terms or like rules and governance that we could lean on together, right? So that way 20 next wave ML companies could address privacy together versus have that be their competitive advantage or disadvantage. And so I think the bar has gotten high in terms of what end users and enterprises need to do business and expect from their service providers. And if we're going to see kind of a flourishing of new operators or new experiences or clouds, I think we're going to need to solve some of those together.
Community building is like a big thread for you.
It is.
I moved to New York in 2010 to start my first company. The community was very different then. You had already been going for a decade, but it was a different kind of vibrant for sure. It's not absent, but it's definitely not as vibrant.
100%.
And so what do you do about that?
Even when I was running hosting company with Raj, we would always talk to all of our competitors. They were our friends. We were working together, and that was kind of the open source ethos. We were very transparent. And luckily, our industries were going up and to the right. We're growing. So it's like all, tides lift the boats kind of thing. And I think we can have more of that today. I see a lot of these independent new cloud providers or infrastructure companies being very siloed. They don't even know each other. Yeah. Let alone, counterparties and whatnot. And I think we need to work together on these things. And the question is who is willing to take the mantle to do the work to bring people together? Like, I think we might be done with the concept of reinvent kind of the conference for every company. Like, why not have one that was just for ML service providers? And we could all come together, and the hallway track would be amazing. And it's not good enough to go to some generic web conference or some Gartner thing where there's too much detail. So I think there's an opportunity there, and I'd love to see some of that because I think some of the muscle died during COVID, and certainly we used to have a thriving meetup scene here. It's why I always lived in Manhattan, was because I could have 8 to 10 meetings a day and still hit a meetup at night, and it's just much harder. And I think we need to find new outlets for that.
Awesome, I love it. It's a call to arms.
Let's do it. We're waiting for it. The primary office is huge.
There we go. Thank you so much. This was a real pleasure and honor to hear you share about your journey. Super relevant, and I have a feeling that a lot of people are trying to learn about this. So it's generous of you to share it, and hopefully it's also encouraging for people to find their way in more, and more to come.
Well, thanks so much for having me. It's been fun.